Preliminary things involved in doing that were projects that brought the experience up a level each time.
The footage you have watched for over 50 years was carefully edited before the world ever saw a single frame. A NASA engineer who helped build the systems behind the Apollo 11 mission later pointed to something far more unsettling than the public was ever shown. During the final minutes of descent, the lunar module began drifting outside of every prediction the engineers had spent years preparing for. Alarms screamed, readings refused to align, and what they discovered afterwards quietly changed how humanity understood the moon forever. 12 minutes that almost killed the first moon landing. The version of the moon landing most people grew up watching is clean, controlled, and almost too perfect to be real. But behind that polished image, the engineers who built the mission were drowning in problems they could barely keep up with. 8 minutes from the Sea of Tranquility, an alarm began screaming inside the Eagle that nobody in the cabin had ever seen during simulations. The computer was, by every appearance, failing right in the middle of the most important descent in human history. Imagine being 240,000 miles from home, watching your only ride to the surface throw error codes you do not recognize, with your life balanced on the next 30 seconds. The alarm was labeled 1202. Then another one followed, labeled 1201. Inside the cabin, Neil Armstrong and Buzz Aldrin had no idea what either of those numbers meant. They had trained for thousands of failure cases, but these specific alarms were not part of any drill they had ever run. Armstrong's heart rate, recorded by his suit telemetry, jumped to over 150 beats per minute. The flight computer was warning them that it was overloaded and was about to shed tasks to keep the most important ones running. The only thing standing between two astronauts and a crater full of boulders was a 24-year-old engineer in a back room named Jack Garman. He was holding a handwritten cheat sheet of computer alarm codes underneath a sheet of glass on his desk. Weeks earlier, during a bad simulation, his supervisor, Steve Bales, had called an unnecessary abort. Garman had quietly written down what every alarm code actually meant so that nobody would make that mistake again. That single sheet of paper became the only reason humanity made it to the lunar surface that night. Margaret Hamilton, the lead software engineer at MIT, had designed the computer to drop low-priority tasks and restart only the critical ones whenever it got overloaded. That design choice was the only reason the lunar module did not crash into the surface during those 12 minutes. Without her foresight, 2 men would have died on the moon. Then came the next surprise. As Armstrong looked through his window, he realized the autopilot was guiding them straight into a field of car-sized boulders. He took semi-automatic control about 500 meters above the surface and began flying the lunar module manually, searching for clear ground. Inside mission control, grown men with families stopped speaking, knowing they were about to witness either history or a funeral. When the Eagle finally touched down, there were only about 25 seconds of usable fuel left in the descent stage. Armstrong calmly radioed back the words that became history. "Tranquility Base here. The Eagle has landed." The Eagle was sitting still on the surface, but the real story of what NASA had found was just beginning to unfold. The rocks that quietly rewrote Earth's history. Once the astronauts returned home, the world focused on the flag, the footprints, and the famous words. But inside secure laboratories in Houston, something far more unsettling was unfolding. The real shock was not what the astronauts saw on the surface. It was what scientists discovered inside the rocks they brought back in 2 sealed aluminum boxes. Imagine the feeling inside that lab, opening containers that held the first physical pieces of another world ever to reach human hands. Apollo 11 returned with about 21.5 kilograms of lunar material. At first glance, the samples looked unimpressive: gray dust, fractured stones, and small, glassy fragments. But when geochemists began dating the samples using uranium-lead and rubidium-strontium methods, the numbers forced everyone to pause. Several of the basalt samples turned out to be roughly 3.6 to 3.9 billion years old. Later, Apollo missions returned rocks pushing past 4 billion years. The scientists looking at those readings realized they were holding objects older than every fossil, every continent, and every drop of water on Earth. Then came the truly stunning result. Some of the lunar highland rocks turned out to be almost as old as the Earth itself. That meant the Moon had preserved geological history that Earth had long since erased through tectonic activity, erosion, and weather. The Moon had become a time capsule of the early solar system. For the first time in human history, we were holding pieces of a world that remembered things our own planet had forgotten billions of years ago. The chemistry was just as surprising. 3 previously unknown minerals were identified from the Apollo 11 samples alone. One of them was named armalcolite, formed from the first letters of Armstrong, Aldrin, and Collins. 3 astronauts who risked everything had their names permanently embedded into the periodic history of the universe. Lunar soil also contained tiny beads of glass, forged by micrometeorite impacts over billions of years. Every atom trapped in that dust was a direct archive of space radiation history that no laboratory on Earth could ever recreate. In the year 1971, Apollo 15, astronauts David Scott and James Irwin recovered a small white rock at a site called Spur Crater. They called it the Genesis Rock because they believed it was a piece of the Moon's original crust. When David Scott radioed Mission Control, he could not contain his excitement. His voice cracked through the radio as he said, "Guess what we just found? I think we found what we came for." That single rock, weighing about 269 grams, turned out to be roughly 4.1 billion years old, a piece of the Moon's first skin, held in human hands. The discoveries also gave strong support to what scientists call the giant impact hypothesis. The idea is that a Mars-sized body, sometimes nicknamed Theia, struck the early Earth roughly 4.5 billion years ago. The collision ejected debris that eventually formed the Moon. The matching oxygen isotope ratios between Earth and lunar rocks, along with the Moon's iron-poor composition, fit this theory almost perfectly. Every time you look up at the Moon, you are looking at a piece of the Earth that was knocked into the sky during the most violent event our planet has ever survived. A fresh angle that few documentaries cover is what the Apollo samples did for the rest of the solar system. They did not just date the Moon. They fixed a calibration scale for every other rocky world we have studied since. Every age scientists now assign to Mercury, to Mars, and even to the moons of Jupiter rests on the cratering chronology built from Apollo rocks. The Moon became Earth's geological Rosetta Stone, and we are still translating what it has to say more than 50 years later. Of course, the rocks were the easy part. Something else came back inside the cabin with the astronauts, something so fine that it shredded vacuum seals on the sample containers, and something so aggressive that one astronaut would later discover, in the most uncomfortable way possible, that he was allergic to the Moon itself. The dust that refused to let go. When Neil Armstrong and Buzz Aldrin climbed back into the lunar module after their walk on the surface, they unknowingly carried with them one of the most underestimated threats of the entire mission. At first glance, it looked harmless, a fine gray powder coating their boots and suits. But inside the cabin, something strange began to happen almost immediately. The dust that had patiently waited for 4 billion years on the lunar surface was about to introduce itself to the human body for the first time. Once the dust-filled suits were pressurized and the helmets came off, the particles began floating through the cabin air. Both astronauts noticed a distinct smell, and they reported it to Mission Control during their post-landing checklists. Armstrong described the scent as something like wet ashes, while Aldrin mentioned a faint metallic note. The dust irritated their eyes and throats almost immediately. NASA flight surgeons recorded mild respiratory symptoms within hours of the crew sealing the cabin. The most expensive spacecraft ever built had just become contaminated by the very thing it had traveled to study. Lunar dust is nothing like Earth dust, and that difference is what makes it so dangerous. On Earth, wind and water smooth particles over time, but the Moon has no atmosphere, no weather, and no water. Every grain of regolith stays jagged and razor-sharp, shaped by 4 billion years of micrometeorite impacts. Under a microscope, the particles look like shattered glass under a magnifying lens. The European Space Agency describes lunar dust as fine like powder, but sharp like glass. Now imagine breathing that into your lungs and rubbing it into your eyes for hours. Even more unsettling, lunar dust carries an electrostatic charge. Constant exposure to solar ultraviolet radiation makes the surface electrically active. This explains why the dust clung stubbornly to spacesuits, visors, camera lenses, and mechanical joints. It was not just sticking, it was bonding through static forces that no engineer had fully prepared for. The astronauts spent hours trying to brush it off, only to find that every motion seemed to pull more dust toward their suits. It was almost as if the moon itself did not want to let them leave. The most striking evidence came from Apollo 17, the final lunar mission. Astronaut Harrison Schmitt, the only professional geologist to walk on the moon, suffered what he later called lunar hay fever after his moonwalks at the Taurus-Littrow Valley. His nasal passages swelled, his eyes watered, and you can hear the congestion in his voice on the original mission recordings. Schmitt was the one who described the dust smelling like burnt gunpowder. Decades later, in interviews, he still spoke about that smell as something he could not quite forget. Astronaut Eugene Cernan, who walked alongside Schmitt, said in a post-mission debrief that the dust inhabited every nook and cranny in the spacecraft and every pore in their skin. The seals on equipment wore down faster than expected. Spacesuit joints stiffened. Engineers began to realize that any long-term lunar habitation would face a major environmental hazard, not from meteors or radiation, but from the dust itself getting into everything. Future astronauts living on the moon for months at a time will have to fight a war against the regolith every single day. A study conducted in the year 2018 by researchers at Stony Brook University added a frightening new chapter. Up to 90% of human lung cells exposed to finely ground lunar simulant in lab tests were killed within hours. Some mouse neuron samples showed similar damage. Lead researcher Rachel Caston noted that the risks of lunar exploration are far more than just the immediate dangers of space itself. Every astronaut who walks on the moon in the next decade will carry a personal medical risk that Apollo only barely glimpsed. The fresh angle that the reference materials often miss is that the dust the astronauts breathed in was, in a real sense, fossilized starlight. Each glass bead in the regolith was forged inside an impact flash created when a tiny meteorite struck the surface at thousands of kilometers per hour. The same hazardous dust also contains traces of a fuel that may one day power fusion reactors, which we will return to before the end of this story. The very thing trying to danger them was also one of the most valuable substances in the solar system. The dust was an enemy they could see and feel inside their cabin, but the next threat was completely invisible, and only one freak of solar timing kept it from killing them all before they could even start the journey home. The invisible gamble that almost cost them everything. Long before Apollo 11 ever launched, NASA scientists already knew that the moon had no global magnetic field and no atmosphere. What that meant, in simple terms, was deeply unsettling. There was nothing shielding astronauts from raw space radiation once they left the protection of Earth's magnetosphere. No ozone layer or magnetic bubble, just open exposure to cosmic rays and solar particles traveling at nearly the speed of light. Every minute the astronauts spent outside Earth's protection was a minute spent inside a cosmic shooting gallery, with no way to predict the next shot. During the mission, small radiation dosimeters were tucked inside the spacesuits and the command module. When the crew returned, the readings showed a total exposure of about 0.18 rad. That was well below immediate danger levels. It was equivalent to a small number of medical scans. But that number came with a realization that quietly changed how NASA planned every mission afterwards. The astronauts had walked through a minefield blindfolded, and only afterwards did the engineers fully understand how close they had come to losing the crew. The mission had been lucky. Radiation on the moon is not constant. It spikes violently during solar particle events. If a major solar flare had erupted while Armstrong and Aldrin were walking on the surface, their thin suits would have offered very little protection. Strong enough solar storm could have delivered a lethal dose of radiation within hours. Engineers later admitted, in declassified internal reports, that the mission timing was partly a gamble. They knew the dice were rolling, they just hoped the dice would land in their favor. Solar activity forecasting in the year 1969 was very limited. Monitoring systems existed, but predictive modeling was primitive compared to today. The astronauts stepped onto the lunar surface during the calm phase between two solar cycles. That calm was a statistical fluke, and it was not guaranteed. The men who designed the mission knew this and went to bed every night during the flight, wondering if the sun would betray them. The proof of how dangerous things could have been came 3 years later. In August of 1972, a massive solar particle event erupted between the Apollo 16 and Apollo 17 missions. According to the National Council on Radiation Protection, if a crew had been on the lunar surface during that storm, they could have received a skin dose of around 600 rem and a deeper tissue dose of 130 rem. That level of exposure would have caused severe acute radiation sickness and possibly death. 3 astronauts could have been alive one moment and dying the next, with their families watching helplessly from Earth. This vulnerability sparked quiet debates inside NASA. Long-term lunar bases would require heavy shielding, possibly burying habitats under several meters of regolith for protection. Later studies confirmed that even a few feet of compacted lunar soil could dramatically reduce radiation exposure. Today, NASA's Artemis program still uses Apollo-era dosimeter data as the foundation for crew radiation safety limits. Every plan to bring humans back to the moon traces its survival math straight back to numbers recorded during those first dangerous days. The fresh angle worth pointing out is that the silent margin of safety on Apollo 11 was the sun itself. The mission flew during a quiet phase of solar cycle 20, and that timing alone may have saved the crew. Future missions to the Moon and Mars will not have that luxury, because longer mission durations make a violent solar event almost statistically certain. Every plan for the next lunar base traces its safety calculations back to the radiation data Apollo 11 brought home. The next generation of explorers will not be as lucky as Armstrong and Aldrin were. The radiation gamble paid off. The dust was contained. But within hours of the astronauts leaving the surface, an instrument they had left behind in the lunar soil began listening to something nobody on Earth had ever heard before. The moon itself was doing something the engineers could not explain, and the recordings would haunt scientists for the next 50 years. When the moon rang like a bell, Apollo 11 left more behind on the lunar surface than just footprints and a flag. The astronauts deployed a solar-powered seismometer in the dust of Tranquility Base, designed to listen for vibrations long after the crew had departed. At first, it recorded subtle tremors from micrometeorite impacts and thermal cracking, as the surface expanded and contracted between the extreme heat of lunar day and the deep cold of lunar night. The moon, it turned out, was not the silent corpse everyone assumed it to be. Then something stranger happened. Later missions like Apollo 12 intentionally crashed the empty ascent stage of their lunar module into the moon. To give the seismometers something to measure, the impact was precise and controlled. The energy released was equivalent to detonating about 1 ton of conventional explosives on the surface. What came back stunned the scientists who were watching the readouts. Engineers stared at the readings and could not believe what they were seeing on the paper recorders. The moon did not just tremble, it rang. According to seismic data released by NASA, the vibrations reverberated for nearly 55 minutes after the impact before fading away. On Earth, seismic waves dissipate within minutes because our planet has water, tectonic movement, and a hot, partially molten interior that absorbs energy. But the moon behaved like a giant, rigid bell, transmitting vibrations across vast distances with almost no energy loss. The readings looked so strange that some scientists at first suspected their instruments were broken. One NASA scientist described the response by saying, "The moon rang like a bell." That single phrase exploded into the public imagination and became one of the most repeated lines in space history. Conspiracy theorists in the 1970s used it to claim that the moon was hollow or even artificial. Books and radio shows amplified the idea, and the seismic recordings became evidence in fringe documentaries for the next half-century. The truth, as always, was less dramatic, but somehow more fascinating. The grounded scientific explanation is far less mysterious, but just as compelling. The Moon's interior is much less geologically active than Earth's. It lacks plate tectonics, has no liquid oceans, and most of its upper crust is dry, fractured rock built up from billions of years of impacts. That dry, rigid composition allows seismic energy to travel longer and dissipate slower. There is no atmosphere, no water, and no moving plates to soak up the shock. The Moon is essentially a giant dry stone, and dry stones ring for a long time when struck hard enough. In recent years, scientists have gone back to the original Apollo seismic recordings and found even more. In the year 2011, researcher Renee Weber and her team at NASA Marshall used modern data techniques to reanalyze decades-old seismic readings. Their conclusion reshaped lunar science. The Moon has a solid inner core, roughly 240 kilometers in radius, surrounded by a fluid outer core, similar in structure to Earth's, but dramatically smaller in scale. 40-year-old data was still answering questions nobody had even thought to ask yet. The fresh angle here is that the Apollo seismometers became the longest-running planetary geophysics experiment ever placed on another world. Some of them kept transmitting until they were shut down in the year 1977 for budget reasons. Even today, every modern theory about the Moon's formation, the survival of its early magnetic dynamo, and the internal heating from buried radioactive elements ties back to data the Apollo crews left in the lunar dust. Those astronauts did not just visit the Moon. They wired it for sound and let it talk back to humanity for nearly a decade. But the seismometer was not the only thing the astronauts placed on the surface. Beside it, they set down a small panel covered in 100 silica prisms. And on a clear night, an observatory in southern France still fires a laser at it, measuring something nobody fully expected when the mission first launched. Something that quietly proves, to anyone who wants to check, that every word of this story is true. The laser that quietly proved everything. On the second day of his moonwalk, Buzz Aldrin set a small white panel down on the lunar dust about 15 meters from the lunar module. The panel was 46 centimeters square and held 100 precisely cut prisms made of fused silica. It needed no power supply, no moving parts, and no maintenance. Its only job was to reflect any beam of light directly back to wherever it came from. It was the most boring-looking object Aldrin placed on the Moon, and yet it became the most important. Back on Earth, observatories began firing laser pulses at the panel almost immediately. The Lick Observatory in California recorded the first successful return within days of the landing. The beam traveled nearly 384,000 kilometers to the Moon, struck the reflector, and returned to Earth in about 2.5 seconds. Of every quintillion photons sent up, only a handful came back, but those few were enough to measure something extraordinary. The data revealed that the Moon is slowly drifting away from Earth at about 3.8 centimeters per year. Over millions of years, that gradual drift changes Earth's rotational speed, lengthens our days, and alters the tidal patterns of every ocean. The companion that has watched over every human story since the beginning is slowly leaving us, and we have the photons to prove it. The same lasers also let scientists test Albert Einstein's theory of general relativity to a level of precision that no laboratory on Earth could match. A fresh angle that destroys every faked landing theory is the international nature of the data. The retroreflectors are routinely struck by lasers from independent observatories around the world. The Côte d'Azur Observatory in Grasse, France, has been firing pulses at the lunar prisms for over 40 years. Stations in Texas, New Mexico, Italy, and Germany have all recorded consistent returns. No conspiracy could fake more than 50 years of independent photon-counting data collected by scientists in countries that have no political reason to support a NASA hoax. The lasers also bring back another quiet certainty. When NASA's Lunar Reconnaissance Orbiter began mapping the moon, its cameras captured the descent stages of every Apollo landing. The cameras saw the lunar modules, the scientific equipment, the rover tracks, and the astronaut footpaths. The moon itself has become a museum that no human curator looks after, holding our greatest achievement in perfect preservation. But the laser-ranged moon is not only escaping us, it is also hiding something that nobody believed could possibly be there for over 40 years, locked in shadows that have not seen sunlight in billions of years. The water, the footprints, and the future we almost forgot. For 4 decades after the Apollo missions ended, one conclusion seemed absolute. The moon was bone dry. Early analysis of the Apollo samples showed no obvious signs of water. Lunar rocks were described as completely anhydrous, formed in an environment that scientists believed had been baked dry by the giant impact that created the moon. The moon, they said, was a wasteland with no chance of liquid or frozen water anywhere. Every textbook for an entire generation taught children that the moon was a barren rock, incapable of supporting any form of life or hydration. Then, in the year 2008, researchers led by Alberto Saal at Brown University re-examined tiny volcanic glass beads collected from Apollo 15 and Apollo 17 samples. Using a technology called secondary ion mass spectrometry, which had not existed during the Apollo era, they detected trace amounts of water molecules trapped inside the beads. The water was not surface contamination. It was internal chemistry, locked away when the beads first formed deep inside the moon. 40 years after the samples were brought home, they were still revealing secrets nobody had known to look for. Just a year later, NASA deliberately crashed a spent rocket stage called LCROSS into a permanently shadowed crater near the moon's south pole. The dust plume kicked up from that impact contained roughly 155 kilograms of water vapor and ice. Scientists watching the live feed cheered as the plume bloomed into view. 40 years of assumptions had just been shattered in a single explosion. In the year 2020, the Sophia Airborne Observatory confirmed water molecules even on the sunlit surface of the moon inside Clavius crater. Permanently shadowed craters near the lunar poles never see direct sunlight. Temperatures inside them can drop below -200 degrees Celsius, cold enough to trap ice for billions of years. The first humans to live on another world will sip water that has been frozen since before the dinosaurs walked our own planet. The same lunar regolith also holds helium-3, a fusion fuel that is almost non-existent on Earth. The same dust that nearly poisoned the Apollo astronauts may end up keeping the lights on for our great-grandchildren. And then there is the most haunting discovery of all, the footprints themselves. The moon has no wind, no flowing water, and no atmosphere to erode them. Studies suggest those footprints may remain visible for 10 million years or longer. Long after every city on Earth has crumbled to dust, those boot prints will still be there, waiting. The small plaque the crew left behind reads that we came in peace for all mankind. The Apollo engineers did not just go to the moon. They left us a map, a museum, and a fuel station waiting for the next generation to claim. Somewhere up there, 12 sets of footprints are still pressed into the dust, waiting for the 13th pair to arrive. If this story changed how you see the moon, drop a comment below and tell us which discovery surprised you the most. Hit subscribe and stay tuned, because more hidden Apollo secrets are coming soon.